Pen 8, Solve Linear Quadratic Systems. In this lesson, we'll look at how to solve linear quadratic systems of equations. So what is a linear quadratic system? Well, let's draw out a scenario here. Let's say you have this slanted surface, and up here a water spout came out, and that water came down in a parabola pattern. And the pattern of that parabola can be explained by the following equation: y equals negative x squared plus 5x plus 18, and the equation of the slanted surface can be described as y equals negative 2x plus 18. So we can consider this a system of equations, a linear quadratic, because one of them is quadratic, plus 18, and one is linear. Remember, the way that we determine quadratic and linear is we look at the degrees. So we have a degree of 2 here and a degree of 1 here. So these intersect, and to find the solution of the systems of equations, we are finding the intersection points of the two. So to find the xy coordinates of these intersection points, first we are going to solve each equation for y. We're going to set the two expressions that equal y equal to each other so that we have equation with only one variable, which will be x, and then we can solve for that x. Now when we're solving for that x, we have some options here. We can use our factoring, we can use our completing the square, or we can use our quadratic formula, because we're going to have a quadratic equation that we're trying to find solutions for. And remember, we can always use the discriminant to check how many solutions we're going to have or what type of solutions they are, to kind of double check ourselves as we go. So let's go back to our system then and see where this takes us. So these have both already been solved for y, so that makes our work easy here. We need to take the two expressions and set them equal to each other, that both equal y. And then we need to go ahead and put this into standard form so that we can use one of our methods of solving it. So we're going to move this over, and we're going to subtract the 18. So we've got negative x squared plus 7x equals 0. So remember, at this point, you get to choose what you want to do. Do you want to use the quadratic formula? Do you want to factor? Do you want to complete the square? I'm going to go factoring on this one because this looks pretty simple here. All I need to do is pull out a GCF, and I'll be in good shape, since I only have a binomial, right? So if I pull out x, that leaves me with negative x plus 7 equals 0, and then I can separate those out, leaving me with x equals 0, and negative x plus 7 equals 0 minus 7. I've got negative x equals negative 7, divide by my negative 1, or x equals 7. Okay, so now that I have my two x values, I still need to find the rest of my ordered pair. So I'm going to put these x values back into the linear equation, which was y equals negative 2x plus 18, and that's going to give me the two y values that I need. So remember, I have one ordered pair that begins with 0, and I have one that begins with 7. So first I'll put in my 0, and obviously that's going to lead me to a y of 18, and then I'll put in my 7, y equals negative 2 times 7 plus 18, and that leaves me with a y of positive 4. So then going back to our original picture, remember we had the slanted surface, we had the water coming up and going down in the parabola. So what we found here then are the coordinates of these two intersection points, this one obviously being here and this one being here. Now as you do this, keep in mind you can have situations where you have two solutions, one solution, or no solution. Let's look at the first system here. We're going to have a parabola that goes through like so, and we're going to have a line that cuts through the parabola like so. So we're going to have two solutions to that system. Our second system here, the linear equation is a horizontal line. So while you have your parabola here, your linear equation gives you this, and so you're only going to have one solution. Now this third one, we still have our parabola up here, but the linear equation does not even touch our parabola. So we have no solutions. Now let's look a little bit more closely at the no solution system, we have y equals x squared plus 2 and y equals x. If we started working through our steps here of trying to solve this, we would see pretty quickly that things weren't quite right. So let's start by subtracting our x on both sides, and we get 0 equals x squared minus x plus 2. And if we do the check on the discriminant, we'll take a b of negative 1 squared minus 4 times a times c, and you can see that we are going to get a negative discriminant, so we have to just conclude no real roots, and in this case for the system, we have no solution to the system. And to practice this, why don't you do number 1 through 6, please?